Hi, everybody. I'm Emily Probst, Managing Editor for Modern Machine Shop Magazine. I'm your moderator for today's webinar, which is sponsored by Gibbs Cam. So let's get this started. You're here because you're interested in the done-in-one concept. Maybe you've faced some challenges trying to complete parts in a single setup, or maybe you're just researching what multitask machining can do for your shop, and you want to find out some more. If you're in the beginning stages of your research, you're in the right place. You'll learn how Gibbs Cam helps you accurately and successfully program your machine to provide you with enhanced precision, reduced scrap, and faster throughput, and more. We'll primarily cover the multitask machining process and configurations as they relate to mill turns and solutions for successful programming of your multitask machine. So, our presenter today is Gibbs Cam manufacturing specialist Chris McBain. Chris did his apprenticeship with the Tooling and Manufacturing Association after attending Illinois State University. Chris has been involved with manufacturing for over 30 years, including time in mold shops, model shops, and manufacturing software development. You can submit your questions to Chris at any time during his presentation using the chat box. I believe it's on the right hand of your screen. And at the end of the presentation, we'll answer as many as we can. So I also want to let you know that this webinar is being recorded and you will receive a link to the recording via email afterwards. So with that, I'm turning it over to you, Chris.
Thanks, Emily. I really couldn't have said that better myself. That was perfect. Thank you so much. Hello, everyone, and thank you for taking time out of your day to join us for this webinar. Today, let's go, there we go. I'm going to define multitask machining. What we call it in Gibbs Cam is MTM. So if you hear me say MTM, it means multitask machining. I'm going to describe maybe the typical machine configurations. I'm going to illustrate some machine types with some typical parts made on them. I'm going to discuss some of the benefits and challenges of programming MTM machines also. Excuse me. And then after that, we're going to go over some of the challenges and how you can overcome them. I had a conversation with one of our resellers yesterday, and he said that something like this, and a webinar like this is so important because so many people are afraid to say, you know what, I'm not sure what a dual turret, dual spindle machine is. And then they end up getting the machines, and not that they can't use them, but maybe you don't know the full extent of the operational value of your MTM machines. Okay, so that's what the idea of this is, to educate, to show the different types of machines, and to show some of the programming techniques. Not really so much, I'm not going to do a demo, but just kind of show you some of the different ways you can program on an MTM. So let's go ahead and get started. So this is just, I already talked about all that. We don't need to go over that. All right, so I'm going to give you a sneak peek at a key portion of this webinar first, right? So really, what are the benefits of multitask machining, right? We can reduce setup. You don't have to go through multiple different machines. You don't have to shut the machine off. This is what we're talking about with the one and done. It machines it from both sides. How does it do that? If you haven't seen it, you're going to see some examples today. And all of the, and one of the biggest problems with doing multiple setups, as we all know, is the errors, right? Whether it's tolerance issues, or I got a chip in the vise or something, or the jaws hit on a chip or something. Whenever you take that part out, as we all know, there's always that chance of error afterwards. So one and done is huge. Again, you're going to increase precision, excuse me, and get way faster throughput. Your machines are going to be working for you. You're not going to be working your machines, or vice versa. You're really going to have that opportunity to get the most out of your machine investment. So let's talk about multitask machines and machines. So at its basic level, multitask machining involves some milling on a turning machine, right? So mill turn machines are capable of both rotating a workpiece and rotating tool operations such as milling. So it cuts by turning, the part is turning, and when it cuts by the tool turning, that's milling. Just to get that out there so we know the difference. The machine's typically recognizable as a horizontal or like a vertical lathe. That's usually what they look like. And the spindles for milling and drilling, they're available at some or all of the tool positions, just like a regular lathe, but we can have live tooling. So let's take a look at some various configurations of these MTM machines. So here we have a single turret, two spindle. So the turret is what the middle thing that moves up and down with the tools on it, and the spindles are on each side. These are the most basic of the machines that can make a part and drop it completely. So when I say drop it completely, as you can see here, it's machining on the left side or the main spindle, and then it transfers, and you're going to see that a little bit, and then finishes machining on the back spindle. So here's another configuration. Here's dual turret, dual spindles. So now we have two actual cutting heads, two turrets that are doing machining operations. These machines, they're usually configured with a lower and an upper turret. As you can see here, the one on the left is the lower and the one on right is the upper. So you're going to have up to 8 axes with this. You're going to have the C-axis, Z-axis, and maybe a B-axis depending on the machine. So this is where programming these machines gets a little maybe complicated. There's a lot of what we call flows, and I'm going to cover that also too. But you want to make sure that all of these cutting operations are happening at the right time. These parts aren't bumping into each other. You're not trying to grab a part while it's still being machined. And so basically what you want to do is synchronize or sync these. And the more spindles, the more turrets, the more important that is. So you look right here, you're seeing 3 turrets and 2 spindles. At this level of machine sophistication, the part complexity typically is such that you can really benefit from that 3rd turret. So the machine is kept busy while both turrets are spinning. Aluminum and stainless steel connectors are a really good example of a part like this for a 3-turret machine. They have a lot of really small features and that range anywhere from 5/8 in diameter to I've seen 2.5-inch diameter or even more in oil and gas. So this is it, man. 4 turrets, dual spindles. This will really this will make parts for you for sure. It's not really common. You can imagine the benefits of this. If you do have parts that have a lot of tools and a lot of operations, this is the one for you. I'm sure a machine tool dealer would be more than happy to quote a machine like this for you. So this is, like I said, you're not going to see a lot of these 4 turret dual spindles, but they're out there and you can get an idea about the spindles and the turrets. While I'm on this slide, I really wanted to cover what's called Swiss style machining or sliding headstock machining. That is also considered a multitask machine, but instead of turrets, they're actually called axes. So instead of a tool holder being a turret here, on a Swiss machine, they're called axes. And that's why if you've ever heard somebody say, oh yeah, I have a 10-axis machine or I have a 7-axis machine, they're not using more of the alphabet. It's not, X, Y, Z, A, B, C, D, E, F, G. It's because each one of those is considered an axis. So let's go ahead and keep moving on here so we don't run out of time. So let's talk about configuration. So right now, what you're looking at here is a B-axis. So until you have a machine with a B-axis, you can't do 5-axis simultaneous machining. You can do positional. The part can move, then you can cut, and then the part can move, and you can cut again. B-axis machining, or B-axis machines, they give you the capability to rotate the milling spindle, machine tilted flat. You can drill and tap holes at any angles that aren't parallel or perpendicular to the center line of the part. So that's a really important signifier. And if you guys are in the market for a new turning machine with live tooling, this is something to consider if you need a live B-axis. So basically what it is one of the milling spindles is replaced with a tool receptacle. I know that's a lot, but basically if you need to do 5-axis milling on your mill turn machine, B-axis is key. So this is what I was talking about with the Swiss style machine. There's some graphics here to wake you guys up so you don't have to just listen to me all day. So now generally we've discussed the most common configures of the MTM machine, and I covered Swiss a little bit. This is what's called a sliding headstock machine under a Swiss, like I said before. They're known as Swiss machines because they originated in Switzerland for the watchmaking industry. So they really high precision, small, very small, not very small, but smaller parts, at least in my opinion. Some of you may work in microns, which these might seem huge to you. I was in a model shop, so I did everything from cell phones to airplanes, so these are tiny. With the Swiss style machine, the part stock, it's actually pushed out of a guide bushing with what's called sliding headstock moves. The advantage of this is you get more purchase on the part. That thing's not hanging out and you're not trying to do machining on the very tip of it. It'll actually withdraw the stock back in. You can see it right here. It goes in and out and completes the machining. So one thing about these machines also, before I forget, is they also have a bar feeder and a parts catcher, which is key. The bar feeder, you don't want to have somebody go there and keep putting these things in all day. So a bar feeder, for those that don't know, it's a big hopper that holds the stock in steel rolls. When this one's done, the next one comes in. So moving up in complexity, there can be a second tool gang or turret, which also works on the main spindle or sub spindle. And that's what you're seeing here. So I'm going to show you just really quick. The next machine I'm going to show is, this thing's amazing. I saw this at both IMTS and I think it was EMO, but yeah, it's great. So let's go ahead and look at that one. So here we have a multi-spindle machine, all right? So this is, if you look at this, the configuration, it's got 6 spindles, not 6 turrets. So it has 6 spindles that do all of its manufacturing in one turret, or I'm sorry, in one spindle. It's typically 6, but in some cases, you might have 8 or maybe in more. They're very complex machines, and you can have access to up to 20 axes. But what we're going to talk about a little bit more today is later on is, you have 20 axes, you can program these. Look at all these moving parts. It's amazing. You're not going to program, well, you could program these by hand, but with all the synchronicity and all that other things involved, it's going to be pretty difficult. So you have to make sure that however you're programming these machines, that way you are able to utilize all parts of the machine. All right. So that's really important. So I mentioned that a little bit earlier, but we'll just go on and keep going here. All right. So benefits of MTM, right? So we're talking about reduced setup a little bit. So I mean, these are all the ones that we oops, let me back up. Sorry, I went too fast. These are all the ones that we pretty much know. So you can go stock to finish without anybody touching these parts. I had a customer once doing arrowheads for carbon arrows. And this machine ran 24 hours a day. It had a hopper, it had a part catcher, and they just go clean up the parts, out they go. So it's really great. Set up, amortize. So, you save 2 seconds on the part, but over the long haul, it's going to pay off for sure. The zero or near zero inventory of work in progress, right? I mean, there's no parts laying around the shop that are half done. Like, hey, where's that? What's the story with that? Oh, I'm waiting on this other machine. Because the work in progress is always on the machine. It goes from stock to finished part. So we talked about reduced errors. So let's talk about how that works a little bit. With an MTM, this is an automatic benefit. All MTMs that I know of so far that I have seen are built to be very precise. The companies that make them are amazing. They really put a lot of engineering into these to make sure that they're rigid, which means they're really sturdy, they don't shake a lot, and they're very precise. The only opportunity for errors after setup is really when you have to change the worn out tools, right? Because there you have that human factor and there you're changing out the tools, but otherwise the error reduction comes automatically because you never have to do any more setups. This one is exactly like the last one, but I really wanted to make sure, accuracy, precision, and scrap. Precision, obviously I went over that, but the error reduction, it brings along just with it is higher accuracy. So really what I'm talking about here is repeatability. Making the next part exactly like the first part is huge, right? We all know this, whether it's ISO or just you've got 1,000 parts and you have somebody with a mic sitting there and just checking things off, whatever it is, we know that repeatability is key. And also because of the accuracy of the machines and the repeatability, you can definitely keep tighter tolerances, which definitely lowers your scrap rate. Oh, you can bid for more jobs too. All right. Oops, let me back up. Sorry about that. All right. So some of the other benefits of the MTM, we can reduce setup. We talked about that a little bit. We reduce scrap. We talked about that. Combine those with greater accuracy and higher precision. We've got faster throughput. I mean, I think that's really the faster throughput to me is the key point on this one. These machines are super cool, right? I mean, they look amazing. And if somebody walks into your shop and they see this, then you go, oh my gosh, that's amazing. But that's not why we buy these, right? That's not why we buy these, well, at least I hope not. You buy these because you want to get parts out the door as fast as possible. And we make parts. That's the whole idea of this, is to make as many parts as accurately as possible, as fast as possible. Okay. That lights out operation too. Oh, geez, I'm so clicky today. Sorry, I'm so. That lights out operation. I hinted at it without actually saying it, but yeah, these machines, lights out operation, they can run 24 hours a day. They really don't need to be manned. Once that all of those movements are synchronized and you've got the stock in there and all the tools are set and they're new, you just press go and you can just go take care of other stuff. Hopefully that's the goal of all these machines, is lights out operation. Get as many parts as you can. So it wouldn't be fun if there weren't any challenges, right? So of course, these benefits, they don't come free, because if they did, everybody would have an MTM machine, right? So first, it's machine complexity. It really presents a challenge because the more tools and tool groups or turrets that you have, the more difficult that a setup becomes. There's more opportunity for what we call interference and collision. So, the freedom of movements for these machines, they have to have a movement envelope that may overlap the other one. So there's no missing. So it is possible to crash these machines, unfortunately. It's true. But the small work envelope on an MTM, especially a Swiss machine, it's really tight also. And the part moves back and forth. So and then you have to worry about that part hitting things. So it's really important to optimize or to simulate these tool paths in a good tool path simulator before you go ahead and hit the green button. Okay, and make sure that your post is right too. I'm going to cover that a little bit later. All right, there we go. So with optimization, that's another benefit that I forgot. I put this on this slide, and I apologize. It should have been on the last one. I mean, really, one of the big keys is really optimizing your tool life and being able to record how many parts, how many hours, how many minutes, what material tools have been on, because they're going to be on the machine and they're going to run until they can't run anymore. So you'll have a really good idea how to do that. Okay. So I talked about these parts hitting each other, right? And each one of the turrets and each one of the spindles is called a flow, right? And each one of these flows, they have to be synchronized. So at Gibbs, we define these flows as the part program for each tool group or turret, right? So each one of these tool groups, each one of these turrets is its own flow. And really what it is, it's a flow of operations. So a machine with 2 turrets has 2 flows, 3 turrets has 3 flows, and so on. In some controls, like the Siemens controls, which actually, here's a shameless plug for Modern Machine Shop. I saw tomorrow, I think there's a Siemens presentation. So you might want to check that out. But on the Siemens machines, they're called channels. In others, they're called paths, or like 2-path or 3-path control. Citizen users, believe it or not, they'd use $1, $1, $2, or $3. I think that's because Citizen machines are so good that you need a lot of dollars to get them. So that's how they call their flows that. So actually, really funny enough, the reason they do that is because each flow is controlled by a $sign in the posted code. All right. So more challenges. Seems like there's more challenges than benefits, but I promise there aren't. A big challenge is really programmer knowledge, right? Which may seem like an obvious prerequisite for this, like you have to know how to program this. But there are many shops that once they get the machine, they discover that there's a lot more to it than just, I'm going to mill this part, I'm going to turn this part, just like on the mill over there and the lathe over there. programming an MTM is much, much more than just knowing how to program a lathe and a mill. So operator knowledge might be a challenge also. If there's insufficient training on this type of machine. Now, okay, let me say this about the challenges. They're challenges, but they're not deal breakers. I mean, these are just, I want to be honest with all of you about things that you are going to experience when you get this machine in your shop and you plug it in. Okay. So, an operator knowledge, that's not that's not something that you can't overcome for sure. It's all about training, right? So if there's sufficient training on the type of machine, they're going to either from the software company or from the machine tool manufacturer. That's really, really going to help. All right, so next. So this one's really huge. So the idea of this presentation is to make it for people that may not have, or for customers, machinists, I don't know, whatever you would like to identify as, to get an idea of how these machines work. And one of the ways that it works, in case anybody in the call doesn't know, is post-processing. What post-processing does, it takes that cartoon that you see on your screen and turns it to text that the machine can read, right? And that translation is very, very important. When you use a CAM company, when you use a CAM system, you have to make sure that they have a good post-processor for your machine. Everyone will say yes, I promise. Every CAM system will be like, yeah, we can write a post for that. Hold their feet to the fire for sure. I mean, make sure that they test it before you buy it, and that they can for sure give you something that can run your machine. Okay. All right. So when you move into the machine, when you kind of move into that MTM world, things change a lot. There are a lot of things going on at the same time, and you can have various moving components, just like I said before, and that post-processor is not only hard to say, but it's also crucial for your success. All right. This is something to really note when you're shopping around for CAM systems also. One of the sub-challenges, as we call it, for post-processing is that there's no such thing as a generic post-processor for an MTM machine. I'm sorry, I should have posed. That's something I should have led with. It's something that I kind of know. I do know that I just kind of assume everybody knows. Because you buy a Mazak or an Akuma or a DMG Mori machine with a Siemens controller or a Fanuc controller, they don't have post-processors that are specific for that setup. Each machine, depending on the options that you get on the machine, needs its own post-processor. Now, when I say its own post-processor, you'll hear CAM companies say, oh, we have basic post-processors that we can modify for your needs. That's fine. That's totally legitimate, but you have to make sure that you know what those needs are. So work really closely with the company that's making your post-processor to make sure that not only they write a post for your needs today, but they write a post that can run all of the moving parts for your machine 3 jobs away when you get something crazy and you don't know how to do it. And all of a sudden it's like, hey, I need that, I don't know, through spindle coolant or something that you didn't have up there before. There's a pretty basic example that you get. So let's talk about the last challenge. It's part prove out. You never want to prove out the part at the machine, right? Everything would be proven out before it gets there. What I'm talking about is simulation, right? And this can be achieved in a couple different checks. So rendering the part how it cuts, a machine simulation. That's what you're seeing here on your screen. There's some animated versions of this coming up. This is really what helps. There's a bunch of companies out there that have third-party solutions for machine simulation. Most CAM systems have their own solution. Most are pretty accurate. Some are more accurate than others. And again, I'll get to that in a little bit. All right, here we go. Here are your solutions, right? We talked about problems, let's talk about solutions. So the primary solution, the challenges of MTM is really having a modern, up-to-date CAM system. If I'm not going to do it, I'm not going to punish you with doing it, but if I went back to one of those first slides talking about the machines, there's a lot of moving parts there. There are a lot of tools to offset, tool numbers, tool holders. There's a lot of things that can be added to these machines that may not be modeled in a regular CAM system. What we call that is intermediate tooling. It's like a right angle head. It's anything that goes in between the tool and the tool holder. Some may have high RPM spindles like that go into the holder, that third party high RPM spindles, the air spindles. that would be intermediate tooling. These are things that you have to see if you make sure that your CAM system is ready to handle, right? So templates, tool operations, we went through all of that. Excuse me. Because really, I mean, matching tools to turrets is fine. Anybody out there that has used lathes, most people, they set up the lathe, they put the tools in there, and then they machine each part with the tools that are in there, and the tools live in there most of the time. It's fine. I mean, there's nothing wrong with that. So, but you want to make sure that those tools are modeled correctly, they're set off correctly, and that they're documented correctly in any kind of setup sheet or traveler or things like that. All right, speaking of which, let's talk about the travelers. That's what you're seeing here on the right. And what would actually, funny enough, I used to call these setup sheets, which I think most people do, but somebody's called them a traveler, and I just thought it sounded really cool, so I called them. So these are the setup sheets that you can either email, text, or print out and give to your machinists with the tool lists, what they do, setups, all these other things. Another thing that's key, because you're going to have a lot of tools that are doing a lot of things. You want to make sure that the operator or the setup technician has a really good understanding of each one of these. Okay, so great. I've got a CAM system. I got a machine that can do more than what I want it to do. I've invested for the future. This is amazing. I've got everything I need. I've got the tools. I've got the operator. I've got everything. I'm going to go to my CAM system now. One of the issues with mill turn machines is because even though it's been around for decades, I think, as we all know, it's relatively new in the world of machining. You know, I think anything that wasn't run by a horse originally was probably could be considered new in the manufacturing industry. That being said, there's a lot of solutions out there that may not have been specifically made for MTM machines. What I'm saying is there may be some solutions, CAM solutions out there that said, oh, wait, these MTM machines are coming. Well, you know, let's just take our milling and our turning and blop them together, and here you go. Good luck. The problem with that is, you can imagine, if it's not made for MTM, MTMs are so specific, you lose track of things. You know, things end up, well, am I going to machine it turning? Am I going to machine it milling? You may need two different CAM systems for that, depending on which CAM system you buy. So you really, really, really want to research that first. All right, so let's talk about those multiple moving parts. So we talked about the post-processor to get that machine moving the way you want. We talked about the CAM system and tools. You want something that's easy to use and easy to navigate through. And this is key too. So when you have multiple moving components, you know, it could seriously be hazardous, not just to your machine, but to your health and the health of your machine, right? I mean, you really have to be careful. So you need to be able to control the motions of these machines and components and to move them at the proper times. And you need to keep it safe at the home position, right? So if it's done machining, let's say that one of those turrets is done machining and it parks, we call it parking. It's not doing anything, it's just sitting there. You need to park that up and out of the way. So you need to make sure that there's a move that moves that out of the way so the other one doesn't, or the other turret doesn't get in the way, right? So a modern system like Gibbs Cam will have this sync manager included with it. So here's a good animation of what we're looking at. And the sync, or what we're talking about, the sync manager allows each operation tile. That's what we're seeing here on the right-hand side is an operation tile. And it lets, excuse me, it allows each operation tile to, you know, to move it around. So you can actually move these flows back and forth. Oh, wait, it's doing this turning here. I want to hold that off until the very end. You can come here and just move these flows back and forth and organize these, simulate it, and you'll get a very, very accurate representation of what it's going to look like when your machine cuts the part. So operation simulation. So let's talk about not just the different parts of the machine crashing on each other or hitting each other. Let's talk about the tool crashing into the part, right? So here's a really good part with a part transfer. You saw it right there. And you can see that this, you know, they look at the turret. So this is actually a wheel on the Mars, on the old Mars rover, the one's a couple years old. There's a lot of cutting and a lot of moving here. And we want to make sure that not only the machine doesn't hit, but the tool doesn't hit, right? So for just a tool path prove out, you're going to need to render the part as machined by the tool path. And that's what you're seeing here. So just to be clear, so what I'm doing, the flow of this, for those of you that are new, you assign these tools programs. You say, I want to cut this section and then you put in all the parameters, and then it calculates it. So how do you know if what it calculated was correct? This is how you do it. Once you put in all the parameters, the feeds, the speeds, the offsets, the patterns, whatever it takes, whatever you've used to program that operation, that tool, it'll show up here. So this is really important, is the simulation part of any CAM software. All right, so we talked a little bit about toolpath simulation. Now let's talk about operation simulation. So an operation is something that is a single, let's say, procedure that uses several different tool paths. You can see here it's machining from the top, it's machining from the bottom. Those are two separate tool paths. When you combine them, it's called an operation. And in Gibbs Cam, we include something called operation simulation, or OpSim. So if you don't want to see the whole machine, if you just want to see, oh, wait, what are these two tools doing? I don't have to rotate my whole machine around to see it. You can just do an operation simulation. The other thing about operation simulation is that it'll actually warn you, right? It'll send up an alert if you have a tool interference or part interference. So for example, if you're doing a facing operation with one tool and the other tool wants to come in and do some drilling or something on that face, the simulation would automatically say, hey, hold on. What I'm trying to say is you don't have to look at this and inspect it and zoom in really close and say, oh, if it crashes, the tool, the non-cutting part, of the tool or any kind of non-cutting part of the machine, you're going to get a big red flash. It's going to say, whoa, 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 something hit. So then you can go back into the sync manager, like I did on the other screen, fix it, rerun it until it looks great. Because again, the whole goal here, set it and forget it, just one setup and we're off to the races. Okay, so I talked about the operation setup. So this is what I've been showing so far, is the actual machine simulation. You can see here, you can get a really good idea. Look at that top turret and the space in between the top turret and the bottom turret. It's pretty tight stuff right there, and that's pretty scary. But with machine simulation, we can make sure that there's no collisions. All right. This is what would be used after you do the program simulation. You're programming, okay, none of the tools are hitting, the sync's good, all the tools are hitting at the same time. Let's go ahead and take a look at what it looks like with all of the kinematics, the moving mechanical parts of the machine when these go ahead and run out. So, maybe you want to come into a part and close the chuck with a tool in the B-axis. Maybe you want to clamp the part or transfer the part after the tool change. There's little things like this. Like, you can imagine that the sky's the limit with these. When do you want to transfer the part? When do you want to cut this certain feature? This is what the sync manager does, and this is what machine simulation proves out. So let's talk a little bit about Gibbs Cam. I know I have to, though, right? This is how I put steaks in the freezer. So honestly, I've been around for a long time, as Emily told you in the beginning, and Gibbs Cam, I used it back in the 90s, and I missed it until I started using it again. It is a really good, powerful solution. One thing about Gibbs Cam, I'm going to put this out there, and this is really important. We can simulate, and we can write post-processors for any CNC machine, no matter the number of spindles or the number of turrets. Okay, that's really important because there's not a lot of mid-range CAM systems, and I say mid-range, I mean price-wise, that can say that we can simulate and post-process any CNC machine on the market, either now or in the future. It has a lot to do with a lot of the technical stuff in the background, how we can assign axes and things like that. I'm not going to bore you with that, but just know that no matter what machine you buy now or you decide to buy in the future, Gibbs Cam is going to be able to program it for sure. So we talked, these are a couple of the options that you get for free with Gibbs Cam. The last one was Value Turn, which is an optimized turning roughing operation. And we kind of saw that go here. This is actually Value Mill, which is a milling version. And I had to speed it up a little bit because, kind of running out of time, but you can see instead of a regular offset pocket pattern when it's roughing, what it does is it makes a series of turns and curves and arcs, and it keeps the tool from digging into the part. Again, the wireframe version of this comes free with Gibbs Cam, same with Value Turn. So there's some time savings and tool savings right there. All right. So I want to talk a little bit about what I've talked about. And I also want to talk about how that does really fit into Gibbs Cam because it really is a really good solution. And I wish I would want to unmute you, but then everybody would start yelling at me. But I'd be really interested if you guys put in the chat. And it's honest, just be honest. You're not going to hurt my feelings. What is your image of Gibbs Cam? I would love to hear that. I would really like to hear it. Like I said, I've been using it forever, and I really like it. But I don't know how you feel, and I really want to know that because I want everybody to know that Gibbs Cam is not that old. Oops, sorry. Look, I was using my hands to talk and I hit the button. Gibbs Cam is not that old rickety cam system that you saw that old guy in the corner of the shop use. It's not. It's not at all. It's not even close. It is one of, if not the most powerful cam solutions on the market. And how do we say that? Like, how do we say, oh, you're most powerful? Everybody says that. All of our competitors say that. Well, here's the reason, right? So we have a unified interface. So we have one interface to do all of your MTM programming. If you're taking notes on this and you're taking notes on things to ask your cam company or your cam supplier, if they can do things, really write down each one of these because it's really, really important. If you know what, if you don't choose Gibbs Cam, I understand. There may be something that fits you better. I get it. But I'm telling you, these are the most important parts, and we have each one of these for sure. So the unified interface, it's key. Sync manager, you want to be able to easily and quickly manipulate how those parts of the machine move around for sure. We talked about optimization analysis. That's a lot of words for simulation. Basically, you just want to simulate the toolpath. You want to make sure that it works. You want to be able to make sure that not only that it works, but that there's no crashes, it's efficient, and it's the path, it's making the part that you want. All right. Reports, I gave that. Those are the travelers that I was talking about, the list, and post-processing. Now, I leave post-processing. Again, I don't know how I cannot say that word. I've been doing this forever. Post-processing for the last because it is the most important. You can have the flashiest cam system. You could have the most top-of-the-line additions to this cam system. You could have the guy running this thing that's amazing. You could program this wheel in half an hour, no problem. If you can't get that to the machine, it means nothing. Right? If you get that flash cam system, and then you can't get your machine to run, that's a problem, right? So make sure that you ask the right questions about post-processing. Have you wrote posts for this kind of machine before? Do you have customers with a similar machine that have been running this post? Things like that. I mean, really get the good questions ready. But these are the ones that you really want to ask when you get up there, all right? So let's talk about post-processing just a little bit. So we discussed it a little bit about the challenges. And like I said before, it's really important that there's no generalized posts for the MTM. No one can say, oh yeah, that's just an Akuma. Whatever, we have posts for that. Anybody out there, by the way, that uses Akumas will know there's no such thing as just an Akuma because they're superpower machines with a really interesting code layout for their G code. By the way, we totally support them. We work with them. One of our AEs, I think, is there right now, actually, in North Carolina, working with them. But anyway, so you're going to hear your cam vendor say that he already has a post. I can't. Now, let me say something just really quick. I'm not pushing our post processors. This is honestly got true across the board. You need a good post processor for any MTM machine. Let me back this up a little bit. So they have to be for your specific machine. I talked about that before. This is funny too. And I wrote this down like last night really quick. Is making the post work, it isn't your job. And I did this for years. Once you post it, you don't have to go in there and say, oh wait, I got to put a percentage sign here, or oh wait, I got to put a space after my tool change, or oh no, wait, my G 62 has to be over here, it's up here, not here. That's not your job. That's the job of the people that write your posts. You should have a rock solid post that you could hit post, hit the green button. That's it. If a cam company says to you that that's impossible, start shopping around, because that is the goal, is, set it up and then forget about it. We just have a few more slides here. Don't worry. We're just finishing up. So here's our solution. You can see here that we've written posts. Actually, I got that number, that's 1,600 a little while ago. We're pushing 2,000 posts now that we've written for high-end machines. I don't know if you see your machine here. There's actually a bunch of machines on here. I got this list from one of our resellers in Europe. I've never even heard of some of these. Maybe you did. But that speaks volumes. We've made machines not just for the big guys, but for the little guys too. So no matter what you need, just know that we got a post for you and we can make that machine work. Now, please, I want to note this also for any CAM company, for us, for any of our competitors, making a good post processor, it takes a little bit. All right, you're going to get a working post processor really quick from anybody, but getting one that works correctly could be a week or two, depending on the machine. Right. So that's another thing also. Talk to your CAM companies about how long it will take for you to run your first job. All right. That's really important also because you got this investment. You want to make the most out of it. All right. So let's go ahead and wrap up here. All right. So MTM machines, right? We talked about different configurations. I defined the various types of the machines. I've shown you various, dual spindle, dual turret, all that other stuff. I covered the key benefits of using the MTMs and the great value, and really it's value. There's what we're talking about. Price, forget it. They're the machines themselves. They're an investment for sure, but they're valuable because they can pump out machines pump out machines. I wish they can pump out parts really fast and really accurate for any of your needs for sure. All right. So then next, I went ahead and I covered the challenges. So, what are the worst case scenarios or what are you going to run into? I couldn't even imagine, knowing that an MTM machine is the solution for my shop and then getting it on the floor and just looking at it like, I don't know. I mean, I know that would be a horrible situation. It'd be a horrible situation for the machine tool dealer, but I'm a mill guy. So, I mean, I would look at this lathe like, I don't know the milling part, but so there are some challenges, but we also talked about the solutions, not only the solutions across the board, but solutions that we at GibbsCAM can also really, really help you, right? So like GibbsCAM, with the ease of use and flexibility that you have, I'm actually seeing some notes here. It's funny, I just got distracted. I'm sorry. Someone said they've been using it for 12 years with 5-axis. They try out different software twice a year. They haven't found anything yet that can beat GibbsCAM. I swear, I could take a screen grab and show you, but it's amazing. I'm so happy to hear that. But that's it. I mean, we're simply powerful, powerfully simple. And we have solutions for any of the challenges that you guys can come up with. Okay. Excuse me. So these are the biggest selling points. When you ask around, make sure that your CAM systems that you're looking at can compete with each one of these, because I'm telling you we can beat them, but you want to make sure that if you choose something besides GibbsCAM, that each one of these is covered, right? You want something that's easy to use. You don't want to spend a ton of time training. You want one interface. You want to be able to use that. When I say one interface, some CAM companies, when you say, okay, I'm going to do the turning part of this mill turn, and now I'm going to do the turning or milling or another thing, they have you open up a whole nother window to do that, and then you combine them at the end. With GibbsCAM, you have one single interface. Here's the milling part, here's the turning part, combine them, sync them, go. And this is actually pretty, so one of GibbsCAM's big slogans, I guess, back in the day was for machinists by machinists. And it really does. It programs the machine as you would, right? So it lets you program these machines. Our interface is customizable. You can set up specific flows. Let's say, for instance, there's a bunch of buttons that you never use. Get rid of them. If you want to make it easy for maybe a programmer that's coming up, just give him access to the part of the program you need, and it's going to program it the way that you want him to program it or the way that he needs to program it. Again, we talked about the sync and automation tools. I think if I say post processors one more time, someone's going to drive here and punch me in the face. So I think I'm going to stop with the post processors. Just know that they're super important. Okay. All right. Here's a quote from one of our customers, Brent Beistel. Really cool guy. Really super, super sharp. You can read this if you want. I mean, everybody has these testimonials, but Brent's great, and we really helped him out with his shop. We got him up and running. He uses a bunch of different solutions that we offer for GibbsCAM, be it MTM, milling, 5-axis milling, you name it, EDM, we have that. You just need, and Brett knows it. We will grow with you. If you're doing mill turn and all of a sudden it's like, oh no, I need a 5-axis, I don't know, pick a machine, OKK machine in the corner, like a vertical machine center. We got you. We'll take care of you. We can program that machine. We can write a post for that machine. No problem. All right. So that actually is it for the presentation. I'm going to go ahead and take questions now.